Now we found both coordinates of our answer. To write the answer, we write the ordered pair 4, 1. The ordered pair 4, 1 as our answer. The only thing left is to check. Since we have equations, we can check, and it's wise to do so. So we're going to check 4, 1 in our equations. Remember that we have to use both of the original equations, the x plus 2y equals 6, and the x is equal to y plus 3. So let's check both of those. We'll begin with the first one. X plus 2y is equal to 6. We're going to fill in 4 for x and 1 for y. And so in our check setup with the T formation that we usually use for checking, we have a space for the x plus 2 times a space for the y on the left, and on the right we have simply 6. The x value is 4 and the y value is 1. Simplifying on the left, we have 4 plus 2. On the right we have simply 6, and of course on the left we get 6. 6 equals 6 checks out exactly right. For the other equation, x is equal to y plus 3. The T format, we have spaces for the x number and for the y number. The x number is 4. The y number is 1. And so we get 4 on the left and 1 plus 3 or 4 on the right, and that checks as well. Notice that the checks in these were simple, in fact almost trivial. Could you have done these in your head? Could you have mentally filled in the 4 for x and the 1 for y to check your work and thought 4 plus 2 times 1 equals 6? Could you have filled in the 4 for x and the 1 for y in the second equation to get 4 equals 1 plus 3? Of course you could. The check is wise to do, and you can do much of it in your head, or of course you can use your calculator. Let's look at another example. This one is not set up so obviously for the substitution method. We have 3x subtract y is equal to 5. 2x plus 5y is equal to negative 8. We would like to use the substitution method for this. This means that we want to get one of the letters by itself in one of the equations. Notice that we do not already have a letter by itself. We could solve for x in the first one. We could solve for y in the first one. We could solve for x in the second one. We could solve for y in the second one. We'd like to choose whatever would make the job easiest. Notice that if we solve for x in the first one, we would begin by adding y to both sides, and then we would have to divide by 3, which would give us a fraction. The same sort of thing would happen if we solve for x in the second one. If we solve for y in the second equation, we would get rid of the 2x by subtracting 2x. We would then divide by 5, which would give us a fraction. For the y in the first equation, when we subtract the 3x and then divide by negative 1, the negative 1 would result in integers rather than fractions. And so the smartest choice would be to solve for y in the first equation. So let's do that. Let's solve for y in the first equation. We can begin by subtracting 3x, or adding its opposite. So we have 3x subtract y is equal to 5, changing to 3x subtract y, subtract 3x, is negative 3x plus 5. Remember that subtracting 3x is the same as adding its opposite. The 3x subtract 3x cancels, leaving you with the opposite of y. And on the right-hand side, negative 3x plus 5. Now the understood coefficient of y is negative 1. To get y by itself, we divide by negative 1. Dividing by negative 1 on both sides gives us y on the left. And we can decompose this fraction on the right to get negative 3x over negative 1 and 5 over negative 1. This gives us positive 3x plus negative 5, or 3x minus 5. So we've got the y alone from the first equation. Remember that we used equation 1. We used equation 1. This is the equation that we have used to get the y by itself. That means that for our substitution, we will take this y expression and fill it into equation 2. This expression will be filled into equation 2 in place of y. This will give us 2x plus 5 times the y expression is equal to negative 8. 2x plus 5 times the y expression is equal to negative 8. The y expression is 3x plus negative 5, or I'll write it as simply 3x subtract 5. Now we have a single equation, one variable, x. We can solve this equation by first simplifying the left-hand side. 2x plus distribute the 5, and you get 15x subtract 25 equals negative 8. 2x plus 15x is 17x, so we have 17x subtract 25 is negative 8. To remove the 25 that's subtracted, we add 25 to both sides. 17x subtract 25, add 25, equals negative 8, add 25. On the left, the 25's cancel, so we have 17x. On the right, we have 17. And now dividing by 17 on both sides gives us the answer, x is equal to 1. And so here's our x value. Our x value for this problem, x is equal to 1. To get the y value, we must back substitute. Let's back up through the problem and identify possibilities for use. Notice that we can't use any of these as we go back up that involve only x. We must find something that involves both x and y. Here's one. This involves the x and the y. Notice that the letter we're trying to find is y, and in this form the y is already by itself. And so if we fill in the x number, it will be a simple task. We could go earlier. We could go all the way back to the beginning. But if we do, we're going to have more of a job to handle in getting our y value. And so the smartest choice is the one that we've already used for substitution. So let's use this one to fill in the x value. This will be our back substitution equation. So here's our back substitution equation. Y is equal to 3x plus negative 5, or 3x subtract 5. We're going to fill in the x value. The x value is 1. And so we have 3 times 1 subtract 5, which is 3 subtract 5. And 3 subtract 5 is negative 2. And so we get y is equal to negative 2. Now the ordered pair is 1 for x and negative 2 for y. And so we get 1, negative 2 as our solution. The only thing left is the check. Remember that the check must always be done in the original. And so we check in the original two equations. Our first equation, 3x subtract y equals 5. We're going to fill in the x and the y values. 3 times the x value, which is 1. Subtract the y value, which is negative 2. On the right-hand side, we have simply 5. 3 times 1 is 3. Subtract negative 2 means add 2. And we get 3 plus 2, which is 5. 5 equals 5. Checks. Then for the other equation, we have 2x plus 5y equals negative 8. 2 times the x expression plus 5 times the y expression equals negative 8. The x value is 1, the y value is -2, and so we get 2 times 1 or 2, plus 5 times -2 or -10 equals -8, and 2 plus -10 is -8, and so we get -8 equals -8, which is true. And so our ordered pair solution of 1, -2 does check.